Now we've also got a variety of overlay methods. So for instance, if we want to integrate data from multiple sources, we can do vector-to-vector overlay, whether that's point in Polygon, line in Polygon, or polygon-to-polygon overlays. We can do vector-to-raster, so you work with that in Lab 2, so I'm not going to go too in detail into this one, but that's like the zonal statistics tool. And then we can do raster to raster overlay, which would be the raster calculator, which I will talk about in a later lecture. I don't want to give too much information all at once, so I'm just going to focus on the vector to vector overlays today because that's mainly what we're going to be doing in Lab 3. So you can overlay polygon over a point to figure out, say, the identity of a certain polygon that it's in. You can do the same thing with line segments, tag them according to the polygons that they overlap with. If they overlap with multiple polygons, then they can get broken into different segments. So you can use the intersect tool to do that. Or you can do a polygon in polygon overlay. And so this is the largest group of vector overlay options, and there's lots of different things you can do with it. We'll work with this quite a bit in Lab 3. So for instance, we can do a union where you have this layer of rectangles and this layer of circles, and you can overlay them, and each has different attributes. So the rectangles has R1 or R2, and the circle has C1. You do a union, you basically merge the layers together and split them based on where they overlap and combine all the attributes. So where it's just rectangles, you'll have just the rectangle attributes. Where it's just circles, you'll have just the circle attribute. And where they overlap, you'll have the attributes of both. So this is useful for aggregating and combining data if you need to merge two layers, for instance. And we can do an intersect instead, and this is going to give us the combined data, but just where they overlap. The intersect is a pretty useful tool. We could do a clip, and that's a simpler version of the intersect. The clip is more like a cookie cutter, for instance, where instead of with the intersect, where you keep the attributes of both, the clip, you just keep the attributes of the layer that would be like the cookie dough. And the clip layer, which is just the cookie cutter, is simply just to cut it. It's not to keep any attributes. Then we can do the opposite of a clip, which is an erase. So an erase would be essentially all the dough that's left over after you use the cookie cutter. So let's just walk through some examples. Let's do a union. So we've got this sirens buffer layer here. I buffered these sirens by 100 meters. And we can see in the attribute table, we've got these different options. We've got the location name, these various attributes. This is the attribute table for the properties. And so we can see that these also have different attributes, the street name, the shape length, etc. So we will union the properties and the buffer and see what happens. So the resulting output merges both together. And if we open the attribute table, we can see if we select somewhere that's just a buffer but has no properties, then it doesn't get the properties attributes, but it just keeps the buffer attributes. If we select a property that is not within a buffer, we have essentially the opposite, where it doesn't get like the street name attribute from the sirens buffer. If we select somewhere that is both, then we end up with all of the attributes filled out. So similar to a union, we can do an intersect. And so an intersect is going to do basically the same thing as a union, but only where they overlap. So if we zoom out and we turn this off, we run it, we see that it does pretty much the same thing as far as the attributes are concerned, but it only keeps them where they overlap, right? So if we open the attribute table for this one, we can see that, again, it has all of the attributes. But if we do a clip instead, and let's say we use the properties layer as the input feature. So the properties is going to be like the cookie dough, and we set the buffer as the clip layer, so it's going to be like the cookie cutter. We run this, visually the result is identical to the intersect. But it's very important to note that even though visually they're the same, they do not end up with the same attributes, right? So the clip doesn't add or merge the attributes. It just keeps the attributes of the input layer. It has nothing to do with the attributes of the clip layer. And so an erase is essentially the inverse of a clip. Again, we'll use the properties as the input, the buffer as the erase feature. We run this. And so this is the resulting output of the erase, right? So it literally does what it says. It just erases the features. So the clip cuts it down. The erase is everything that's left over after a clip. And again, if you open the attribute table, you'll notice that, again, the attributes don't transfer. So with unions and intersects, the attributes from both layers transfer. And for erases and clips, the attributes don't.